Acids. Have you ever wondered what substance gives lemon its acidic taste? Or about the liquid in the car battery? Or have you ever felt heartburn in your stomach? So, what was the reason for this acidity that you felt? These substances are called acids, which is characterized by its sour and tart taste. Perhaps that's the source of its name. Many of these foods we eat or use in our food contain chemicals that we call acids, such as citrus fruits containing citric acid. They also contain ascorbic acid, which is known as vitamin C. As for vinegar, it contains acetic acid, while carbonated drinks contain carbonic acid. And acids are not limited to those that are found in food. For example, a car battery contains sulfuric acid. As for gastric juice, it contains hydrochloric acid, and its formula is HCl. It's important in the digestive process, but the increase in the secretion of this juice is what causes burning pain when stomach acidity is felt. There are also many substances prepared in the laboratory and industry and classified as acid. But most of these substances warn their taste because they are caustic and burning to the skin and tissues, and they must be handled with extreme caution. Therefore, due to the importance of acids and their multiple applications in our lives, scientists have been interested in studying them to identify their properties and interaction. So let's get acquainted together with the qualities of these acids. The first property is that acid solutions are electrolytes. Acids are electrolytic substances that ionize when dissolved in water, and their ionization produces positive hydrogen ions and negative ions that vary according to the acid, which makes their solutions conductive to electric current. But what does it mean? Let's consider the following example. Hydrochloric acid, HCl, as we can see, consists of hydrogen and chlorine bonding. But when dissolved in water, it will ionize, which means that it will dissociate into positive hydrogen ions and negative chloride ions. This is what makes the hydrochloric acid solution an electrically conductive medium. Therefore, acids are called electrolytic substances, that is, solutions that conduct electric current. The second property is the power of acids. Some acids are strong acids, and some are weak acids, and it depends on the degree of ionization of the acid in the water. Strong acids. If the acid is strong, most of its molecules are ionized when dissolved in water, as we see. This leads to the formation of a relatively large amount of hydrogen ions. The acidic qualities are strongly pronounced. Also, the degree of salt conductivity of electric current increases, such as hydrochloric acid. which is one of the strong acids. Therefore, most of its molecules are ionized in water, and therefore the degree of conductivity of its solution to electric current is high. It should also be noted that when writing the ionization equation for strong acids, the arrow is written in one direction, which indicates total ionization. While weak acids, where if the acid is weak, a small percentage of its molecules are ionized, the bulk remains without ionization, and therefore only a small amount of hydrogen ions is produced in the water. The acidic qualities of solution are weakened, thus the conductivity of its solution to the electric current is weak. Like acetic acid, which is one of the weak acids, so a small percentage of its molecules will be ionized in water, and therefore the degree of conductivity of its solution to electric current is weak. When writing the ionization equation of weak acids, it's written with two opposite arrows, which indicates partial ionization. Let's get acquainted with some strong and weak acids and their ionization equations in water. As we can see, these acids contain the hydrogen element in their composition, and it's at the beginning of the compound, as we see, which is in red. Except for carboxylic acids, which are in the RCOOH formula, the hydrogen atom that is ionized is at the end of the compound. But there are other substances whose aqueous solutions have acidic qualities, although the hydrogen does not include in their composition, such as the aqueous solution of CO2 and the aqueous solution of SO2. Since CO2 gas reacts with water to produce carbonic acid, this acid is present in carbonated drinks, as mentioned at the beginning. And this acid partially ionizes in water, producing H+ ions and HCO3- ions, as we see. As for SO2 gas, it reacts with water, producing H2SO3 acid, which is ionized in water, producing H+ and HSO3- ion. So, in general, aqueous solutions of nonmetal oxides are acidic. The third property of acid is that acids react with metals. The acid reacts with the active metals, resulting in hydrogen gas and a methyl salt. The active metal replaces the hydrogen contained in the acid. For example, when the sodium reacts with hydrochloric acid, the sodium element replaces the hydrogen contained in the acid, produces sodium chloride, which is table salt, and produces hydrogen gas. Therefore, it's not recommended to cook food containing acids in aluminum containers in order not to react with acids contained in food. But how can I distinguish acid solutions from other in a safe way? Especially since most of them weren't tasting them, because they are caustic or burning to the skin and tissues. So let's figure out how to detect acidic solutions together. For this, substances called indicators are used. They are substances that change their color depending on the type of solution they are in. Some of them are natural and some of them are industrial. Natural indicators, which are tea and red cabbage. So when you put the acidic substance in the tea, as we see, its color changes from red to yellow. While when using cabbage, as we see, we notice a change in its color from purple to red. You can try it at home to detect acidic solutions. As for industrial indicators such as litmus paper, some of them are blue and some of them are red. But for the detection of acid, we use blue litmus papers. Notice how their color changes in an acidic medium. As we observe, their color changes from blue to red. There are also chemical indicators such as methyl orange, which turns red in an acidic medium. Big thanks for watching. At the end, don't forget to like, share, and subscribe to receive my new videos.